Soy-rich diets have gained significant attention for their nutritional benefits, including high-quality protein, fiber, and an array of micronutrients, as well as their role in supporting heart health, bone strength, and overall metabolic function. At the same time, soy is distinct in its content of isoflavones, plant-derived compounds classified as phytoestrogens, which can interact with estrogen receptors in the body. These phytoestrogens have the potential to influence hormone levels, metabolic processes, and other endocrine functions, and emerging research suggests that their effects may vary between men and women, reflecting differences in baseline hormone profiles, receptor sensitivity, and metabolic context. While some studies have raised questions about potential endocrine disruption, a deeper examination reveals that soy can be safely incorporated into diets, offering benefits while its effects on hormones are nuanced, generally modest, and often positive. Isoflavones are structurally similar to endogenous estrogen, allowing them to bind to estrogen receptors, particularly the beta subtype, and exert mild estrogenic or antiestrogenic effects depending on hormonal status. In women, particularly premenopausal women, soy isoflavones may subtly modulate estrogen activity, potentially supporting hormone balance. Research has shown that soy consumption can alleviate mild menopausal symptoms, such as hot flashes, and may improve bone density by enhancing estrogenic signaling in bone tissue. These effects highlight a positive aspect. Phytoestrogens can act as selective modulators, supporting physiological processes without overwhelming the endocrine system. In younger women, moderate soy intake does not appear to disrupt menstrual cycles, fertility, or baseline estrogen levels, indicating that the endocrine impact is mild and context-dependent. In men, the influence of soy on hormone levels has been widely studied, with some early concerns suggesting that high soy intake could reduce testosterone or impact reproductive function. However, meta-analyses of controlled trials consistently show that typical dietary soy consumption does not significantly alter circulating testosterone levels, sperm quality, or other markers of reproductive health. Some studies suggest minor shifts in estrogen to testosterone ratios, but these are usually within normal physiological ranges and do not translate into functional deficits. This underscores a positive perspective. Men can incorporate soy as a protein source without fear of meaningful endocrine disruption, while benefiting from its cardiovascular and metabolic properties, including cholesterol-lowering effects, improved insulin sensitivity, and anti-inflammatory benefits. Soy-rich diets also interact with metabolism in gender-specific ways. In women, phytoestrogens may influence lipid profiles, glucose regulation, and bone health, supporting cardiovascular and skeletal resilience. Isoflavones can modestly reduce LDL cholesterol, increase HDL cholesterol, and improve arterial function, complementing the overall metabolic benefits of a plant-based dietary pattern. In men, soy protein and isoflavones may enhance metabolic markers such as insulin sensitivity and blood lipid profiles without negatively affecting hormone-dependent processes. These effects suggest that soy consumption provides a favorable nutritional and metabolic profile across genders, supporting heart and metabolic health while producing subtle, non-disruptive hormonal modulation. The positive aspects of soy extend beyond isoflavones. Soy protein contains all essential amino acids, making it a high-quality plant protein that supports muscle maintenance, satiety, and weight management. Isoflavones may also act as antioxidants, reducing oxidative stress and inflammation, which indirectly benefits endocrine and metabolic function in both men and women. Additionally, soy is versatile and environmentally sustainable, offering a protein source with lower greenhouse gas emissions than animal-based proteins. This combination of metabolic, cardiovascular, and ecological benefits further reinforces the value of incorporating soy into a balanced diet. Individual factors, including genetics, gut microbiota composition, and hormonal status, influence how soy affects hormone levels. For example, certain gut bacteria convert daidzein, a soy isoflavone, into equal, a metabolite with potent estrogenic activity. Only a subset of the population are equal producers, which can partly explain variability in hormonal responses to soy. This variability is not inherently negative. Rather, it highlights the adaptability of the human endocrine system and the potential for personalized nutrition. People can monitor their responses, adjust soy intake, and enjoy its metabolic and cardiovascular benefits while tailoring consumption to individual tolerance and lifestyle context. Moderation and dietary diversity are key. Typical intakes of 1 to 3 servings of soy foods per day, such as tofu, tempeh, edamame, or soy milk, provide sufficient protein and isoflavones to support metabolic and cardiovascular health without causing hormonal imbalance. Combining soy with a variety of other plant proteins, whole grains, vegetables, nuts, and seeds ensures nutrient completeness and minimizes the risk of over-reliance on a single phytoestrogen source. The positive takeaway is that soy is not only safe for regular consumption but also enhances dietary quality, contributing to balanced nutrition, cardiovascular resilience, and sustainable protein intake. Finally, research also points to additional long-term benefits of soy-rich diets. Regular soy consumption is associated with lower risk of certain hormone-sensitive conditions, including postmenopausal osteoporosis and potentially breast cancer in women, and may support prostate health in men. The combination of high-quality protein, isoflavones, and micronutrients contributes to systemic health and metabolic resilience, demonstrating that phytoestrogens can be integrated safely into a diet that supports both endocrine balance and overall wellness. In conclusion, soy-rich diets may influence hormone levels differently across genders, but the effects are generally modest, context-dependent, and often beneficial. In women, soy phytoestrogens can support hormone balance, cardiovascular health, and bone strength, while in men, soy protein and isoflavones provide metabolic and cardiovascular benefits without meaningfully altering testosterone or reproductive function. Beyond hormones, soy contributes high-quality protein, antioxidants, and environmental sustainability, making it a versatile and health-promoting dietary choice. By incorporating moderate amounts of soy within a varied, nutrient-rich diet, individuals of both genders can enjoy its broad metabolic, cardiovascular, and endocrine benefits while maintaining hormonal balance, illustrating that careful dietary planning can maximize positive outcomes and minimize potential risks.